Using the query string in a URI to pass additional data with a GET request is a nice way to fine-tune your request and the subsequent response. For example, a server can make sure that a request to the /search resource is fully accommodated by reading the query string parameter you passed, which would probably contain your search string, say the string Chicago. In putting together its response, the server would include only search results related to Chicago. This is a nice feature of HTTP, but its use is limited to the fetching of results. That is, these GET requests are essentially read-only. But what if we want to update a resource to incorporate the data that we pass it? This requires a different kind of request, a POST request. As you recall, in contrast to a GET request, the purpose of a POST request is to make a change on the server. Maybe update a database record, upload a new file to the server, or possibly delete data from the server. In short, POST requests lead to a change on the server, and in particular, a change to the resource listed in the URI of the request. Recall the scenario mentioned in a previous video where you might be editing a contact's first name using an HTML form. A server receiving this request should update the contact's associated record in the database with the new first name provided. I want to be clear that we won't be looking at how to actually change the resource requested. That's up to the developer of the web application that lives on the server and captures your request. We'll focus here on just the request itself and how it's formatted in HTTP. Let's have a look. In a POST request, additional considerations need to be made. Remember in our HTTP responses we saw a content length header? As a reminder, this specified the number of bytes included in the response body. Now it turns out that in a POST request, we'll be transmitting data in the request body or payload and not in the URI like we did in the GET request, which means we'll need to include a content length header in our request to indicate the number of bytes we're transmitting. For purposes of this demo, I'll simply count the number of characters that I'm using in the data and use that as the number of bytes for the content length. I tell you in the teacher's notes why this works for the demo, so here we go. We'll telnet to httpben.org and issue a POST request using HTTP version 1.1. Again, the host is httpben.org, and the content length header, I'll specify 32 bytes because I'll be passing 32 characters. Make sure to leave a blank line in between the content length header and the request body or payload. Let me just pass a couple pieces of information here. I'll pass my first name and I'll pass a language. Now, I'm sending a POST request to the /post resource here because I know that httpben.org is expecting a POST request at this resource. Usually, the name of the resource won't be POST. Okay, let's make this request. I'll press enter there. Now, I can see that the server received my request and read my data because that data was used in the response that was sent back right here. First name equals Chris and language equals English. Cool stuff. Now, let me show you an example of what might happen if you miscalculate the number of bytes in the request. Let me clear my screen. And I will again telnet to httpben.org and make a POST request. This time indicating the content length header as 30 bytes instead of the 32 that I will pass it. I'll pass it the same data that I did last time. Now, when I hit enter, the response I get is actually not okay. The status listed is 400 bad request. Remember, the 400 level codes indicate an error in the client's HTTP request. In this case, it happened because I sent more data, 32 bytes of data, than what I indicated in the content length header, which was 30 bytes. Now you've seen two ways to send data to the resource listed in the URI you've requested. With a GET request, you'll send the data in query string format by appending it to the URI, starting with a question mark. These GET requests are meant to be read-only in that they make no changes to the server and only return existing data. We also saw how to send data with a POST request. For this, we drop the data into the request body in query string format after the blank line that follows the headers. Speaking of which, we need to add a content length header that indicates exactly how many bytes are included in our POST data. And remember, POST requests are intended to modify the resource requested. All that said, I'm exhausted. When it comes down to it, navigating the web and sending data using our manual method is time-consuming, error-prone, and just plain boring. Wouldn't it be nice if there were a GUI for HTTP? During the remaining part of this course, we'll look at how a web browser gives the everyday web surfer the ability to communicate with HTTP without ever having to look at the protocol itself.